All right, so hi guys, welcome to the first or second webinar, depending on when you join the workshop. So, am I audible? Can somebody quickly, type in the chat and let me know if I am audible? All right, so we'll wait for 2 more minutes. Some people are still joining. So, as soon as we are done with 2 minutes waiting, we'll start with the content. All right, so let's get started. So if you have already checked the group, you know what we're going to talk about right now, and that is how do we actually run all the four different language programs on a Linux machine. So I have a Mac with me, and it is the same in both Ubuntu and Mac. So Ubuntu is the most popular Linux system that is used after Mac, of course. So I'll be explaining everything on a Linux machine, and the process is exactly the same for the Ubuntu machines as well. Again, if you have any doubts, you can leave them in the comments or the live chat below, and I'll try to answer all of those once I'm done explaining. So I'll not be, stopping in the middle of the explanation. So once I'm done, we have 5 minutes for doubt clarification, and that is when I'll be solving all your doubts. And the reason why I chose this particular topic is because a lot of people ask me how this works. And also another important reason is that in most of the colleges, in the software labs, Ubuntu is installed. So even in our college, we have Ubuntu in the labs, and that is what we have to use when we are going for these labs. Right. So that is the primary reason why I chose this particular topic for the webinar. Right. So let us take a look at how we actually implement C programs on the Linux machine. So there are two ways of doing it. One is you download this thing called as the Xcode, which again is Mac specific. So if you go to the App Store, there is this Mac specific software. The problem is that Dev, C++, and other traditional applications do not work well. Right? So even if you try to port them or install it in some way, it does not work well. And the best possible solution to that is already provided on a Linux machine. So Linux comes pre-installed with C compilers, even C++ compilers for that matter, running the terminal. Right. So let me quickly switch to the terminal. Right, so is the terminal visible to you guys? Or can somebody please type in the comments and let me know if it is visible? Alright, so the terminal is visible and I have fixed the sound as well. So let's see how we actually run a C program on the terminal. So this is what we do, right? So there is this thing called as the VI editor, which is pre-installed in a Linux machine. So it comes with every version of a Linux, right? Basically, it's a free software. So what we do is we type VI and we type the name of the file that we want to create. For example, if I want to write a new program, I'll just call it newpro.c. So make sure you have this extension right. So if you are making a C program, make it .c, CPP for C++, and .py for Python. Right. We'll be looking at Java in another software. So for now, let's take a look at C, C++, and Python. So once I have named the file, I'll press enter and it will open a blank file for me, right? So that is basically the editor where I have to write the code. So again, if I am to quickly recap what I just said, we go to the terminal and we write VI, which stands for the editor which comes pre-installed with any Linux machine. And then we write the name of the file that we want to make. Right. So if we are making a C program, we'll write the file with a .c extension. So this is the name with which the file will be saved on your system. Right. So I'm calling it newpro.c, and when I press enter, it will open this blank kind of a thing where I can write code. Right. So now when I press I, you will see that this option changes to insert, and that is basically where we can write the code. So once I press I'm free to write whatever I want. So I'll quickly write the basic syntax that we have. So I'll write stdio.h. I'll write int main. I'll just write this is a C program, and I'll write return 0 because we have written int there. So this is the basic C program that I've written here. You are free to write everything that you want down here. Right, so the entire program has to be typed in this particular place, and then you press escape colon WQ, right? So you can see the command down here. So once you press this, once you type this, you can press enter again. So WQ stands for save and quit. So once we do that, our program is now saved and we come back to the terminal. Right now, to compile the program, we have CC, which is the C compiler, and again we have the file name .c. Now when I press enter, it will again go to the next line, which basically means that there are no errors. Right. So if we do something wrong, or if we type anything which throws an error, we'll get the error in this particular window. So now if since everything is correct, we do not get any error. And for running the program, we have to write ./a.out, right, which stands for the output file which is stored. So once I press that, it will give me the output of the program. So it says this is a C program. Right, so that is basically how you run a C program on a MacBook. Right, so again, VI is the name of the editor. So once we type this particular command, we are taken to a new screen. So if I am to type it again, I'll get back to the exact same thing because I've saved the code already. Right now to save it, we have to press escape and WQ, which is save and quit, CC for compiling the code, and ./a.out, which will basically run the code. Right, so that is how you run a C program on a Macintosh or a Linux terminal. Right. Okay, so is the audio working now? Because everything is working fine on my phone. I have it running parallelly there, and everything is working fine. Yeah, it is. No, it is not. Like GCC is for C++, right? So I'll come to that. CC is the C compiler and GCC is the C++ compiler, right? So that is what we'll be looking at next. So we just saw how to run a C program using a terminal and the VI editor, which comes pre-installed in a Linux machine. Now let me quickly switch back to the terminal and we'll look at how to run the C++ programs. Right, so we are back to the terminal now, and now we are going to start looking at the C++ programs. So for that, again, we have the VI, which stands for the editor, followed by the name of the file. So let me call it cpp hello maybe. And now I have to save it with the extension .cpp, right, which stands for C++. So again, we'll get to the exact same thing. We'll press I and then we can start typing. So let me quickly get the basic code in place. So I've included IOStream. I'll write the main function and I'll write the, so in C++ it is cout, right? So let me quickly write cout and I'll end it. So escape colon WQ, that will save and quit. So we are back to the terminal. And now for running C++ programs, we have to write GCC, which is the C++ compiler, and the name of the file, which is cpp So as you can see, we have errors here, which is on purpose so that I wanted to show you guys that we get errors, right? So a bunch of things. Std cout basically means that we missed, typing using namespace std there. That is one. And the second thing is we have not used int main, right? So these two things need to be fixed. So let us go back. Another quick shortcut is if you press the up arrow key directly, it will go to the last command which you used, right? So the last one that we used was gcc. So you can switch between commands using the arrow keys. So I'll go back to the terminal. I'll go back to the editor and I'll write using namespace std. And I'll also write int main here with the return 0. So it should work fine now. So again, I'll press the up arrow and go back. Okay, so there is something wrong with the code. So let me quickly go back. And instead what I'll do is I'll simply write the printf statement. So let us try running it again. Right, so we don't have any errors this time, so the output is fine. And again, to run the code, you have to write /a.out, and there we go, we get the output hello there, which is what we are looking for. Right, so this is how we make C++ programs on a Linux machine. The exact same code can be implemented in every single C++ compiler. This is one of the compilers that is available, and even Dev C++ uses the GCC compiler only, right? So yes, this code will run on everything. And no, you cannot close the file with Control Z because the first thing is that it is Command Z in the case of a Mac, and the shortcut is :WQ, right? Escape, then you type in :WQ, and then you quit. So that is how it works in the terminal. There is no alternative of doing it because there is no menu here, so you cannot do anything, right? So that was C++. Now let us go to, now we'll look at the Python program. The process is exactly the same. Vi python hello.py. Make sure that the extension is py, and I'll simply write print Python works probably, and that is as well. So let's do it, and here you have to write Python and file name.py. Yeah, so the problem with cout was that there is something wrong with the header file in this particular case. So I'll have to look at the architecture. So as it says undefined symbols here, that is something to do with this particular machine. So don't worry, it will work fine in your system. I don't know what is wrong because this is not my laptop that I'm using. Right, so there is something wrong with the header file. Somebody messed up the code, and that is why it is showing an error. So yeah, that was why the cout thing was not working. See, so the thing is, you can use a lot of text editors, and every single text editor does the exact same thing. So instead of using the VI editor, you can type in Notepad or whatever editor you are using. You can then go to the directory in the terminal and then run the code from there itself. Or you can even drag and drop in the terminal, and it works in few cases. Right. So the editor is not the problem. You need to make sure this particular thing, the compiler part, is done right. So in the case of Python, the name of the compiler is simply Python. So you write Python filename.py and you get the output immediately. So it says Python works. Right. So that is why that is how you implement a Python program. No, so iostream.h wasn't working. I tried it earlier, and that is because the .h extension does not work in many header files. So I already tried it with the iostream.h before the webinar itself, and that was not working. So anyways, it will work fine in your system. So don't worry about the code. I'm just trying to tell you how do you run the program, right? So the code will be different in every single case. So that is not the problem. You just need to understand the terms we are using here, the command that we use here. So vi for the editor, gcc for the compiler, and /a.out for running the program. Similarly, in the case of Python, it is vi for the editor and Python for the compiler. So it will immediately work after you have compiled it. Right. And in the case of a C program, it is vi for the editor, cc for the compiler, and again /a.out for running the code. So that is how you run C, C++, and Python files on a Mac or a Linux machine. Now the thing is, you can run Java programs as well with the compiler, which is called Java C. Right. So you can type Java C filename.java, and it works fine. But there are two problems to that. The first one is that you have to install a JDK, right? So the Java development kit has to be installed first from the Java's website. So that is one thing. And the second problem is that Java takes a lot, like the codes in Java are really long. And if we use a software or an IDE like Eclipse or NetBeans, we get something which is known as automatic code completion. Right? So we do not have to actually type everything out on our own. The code is automatically completed. So that is the reason why I am not using Java here, or I am not going to write a Java program using the terminal. Instead, I'll show it to you in Eclipse. So let me switch to Eclipse. And here we'll run the Java code. So again, two reasons. The first one is you need to install the JDK, which will automatically be installed along with Eclipse. And the second reason is the code completion, which I'll talk about in just a second. So let me quickly open Eclipse. Right, so now we have Eclipse open, and this will not be visible if you open it for the first time. Right, so for the first time you'll get a different screen, and there you just need to close whatever is shown. So you'll get some hints or tips. So just close that, and go to File, New Project. Right, so find this option called the project, select that, and then you can select the Java project, which is the first option. So go to next and type in whatever name you want. So I just call it sample Java probably. And then you can click on finish, which we have down here. So that will create a new project, as you can see, and expand this option here. Go to the source. Either you right click on it or you double tap on it, depending on whatever machine you're using. And you can go to new file, right? So, or the new class. So every single program in Java is a class, right? So now we'll go to class, and then make sure you select this option here, public static void main. So this will basically make it the main class of the program, and I'll call it main itself, and I'll click on finish. So now we have this basic default code in place directly with us, right? So this is the best part about using an IDE. You do not have to type anything out, right? So now if I am to type in system and I hit dot, it will automatically show these things, right? So this is what automatic code completion means. The moment I press the dot here, it will automatically give me a prompt and it will show all the possible options. So I just don't have to type anything myself, right? So I just have to, select whatever I want and the code is written automatically. So I'll simply say hello. That is it. And for saving, you can use Command S or you can go to File, Save, and everything. And for running the code, you have this arrow right here. So I'll click on Run, and the output is shown down here. Right. So you can see this hello down here. That is how it works. So that is how we run Java in an Eclipse. In Eclipse. Right. So Java programs in Eclipse. That is how it's run. You create a new project. You go to the source. You create a new class and give it the public, check the public box and make it the main class, and then you type whatever you want and you can just save it and hit on run. Right, so that is basically how you run Java programs on a Linux machine. Again, Eclipse is free to download for the Linux machine, so you can directly go to the website and download that, so that won't be a problem. And this is the best way to run Java because you don't have to type anything out. You just type in one word, press the dot, and everything else is taken care of. You just need to select the proper option from the suggestions. Right, so that is how you actually run all the 4 different language programs in a Linux environment. And I'll be stopping for doubts now. So if you have any doubts, you can type them out in the live chat and I'll answer those. So let me quickly quit everything and I'll get back to your doubts in just a second. So you can drop the doubts in the live chat and I'll answer those. I'll wait for 5 minutes for the doubts and then we'll switch to the presentation which we have here. For Windows, Linux, Mac OS, and every other operating system that is out there. Right. I think it is available for Ubuntu also. Last time I checked, it was there in Ubuntu as well. So that is not a problem. Eclipse is common and it is a free IDE which is available for all the platforms. Yeah, so as I just said, Eclipse works on all the platforms. You just need to download the proper setup from the website and make sure you download the Java JDK along with it. And if it is not offered along with it, you will have to go to the Java's website and download it separately and install it. So that again is a system specific. So it is a different setup for the Mac and a different setup for Ubuntu and a different one for Windows, obviously. So make sure you have the JDK in place and also make sure that you have Eclipse installed. That is the best way. And in Windows you can use NetBeans as well, which is another brilliant IDE for running Java programs. So both Eclipse and NetBeans run just fine, so there is no issues. You can use any of those. And again, the reason I am stressing on using an IDE for Java at least is that you don't have to type everything out because Java is really a long, Java takes really long to type the codes. very easily using editor is an alternative for the editor that you are referring, and you can type in the GI editor itself or the GI, and that also works fine. So all you need to do is you need to use the CD command on that particular file wherever you have saved it, and you can run it from there. You can just Google the CD command and you just have to mention the path to the file where it is saved, and then the process is going to write cc and filename.c or gcc filename.c++ or even the same for the Python as well. So if you want to use the editor which is embedded inside the terminal, you can type in vi. If you want to use a gedit editor, you're free to use, or even if you want to use text wrangler or any other editor for that matter, that isn't a problem. The only additional thing, if you're using anything other than vi, is that you'll have to use the cd command to locate the file, and then the process is exactly the same. So is that understood, or or should I repeat that? Yes, so both C, C++ and Python compiler use the same editor. So like somebody was asking the difference between a Windows and the Linux environment before we began the workshop. So this is the basic difference, right? So you don't have to worry about taking care of additional software or compilers when it comes to developing or programming, but you need to install additional compilers and everything in the Windows environment. And no, that was not my picture, so I'll convey that it was nice to whoever's laptop I'm using. So yeah, that is the difference between using a Windows and a Linux environment. So is there any other, are there any other doubts, or can we continue to the next section? So I have a very interesting 11 slide presentation to show you guys, which talks about the 10 mistakes which we make while developing our systems. So if you want, you can just type continue or something in the chat and we'll proceed. I'll All right, so let's proceed to the second part of the workshop, which is a presentation. It's a really, minimalistic presentation, but I'll try to explain everything. Now, before I switch to the presentation, what you need to understand is that the things that I'll be pointing out might seem very basic to you or very fundamental to you. But trust me, if you fix these 10 things, most of the problems are automatically resolved. Right? So you will see yourself that you'll be making fewer mistakes if you keep these points in mind. Right, so here we go. Is the presentation visible? Can we start? Yeah, Supratim. So there are additional options in the command. So there are alternative. I mean, there are options that are not compulsory to write. You use those options, you can track the runtime and everything in the terminal programs. So yes, it is possible to track the timing and everything. You just need to use those additional commands for doing that. So you can just Google those out, or if you have any question, drop a message and I'll get back to you. Right. So let's get started with the presentation now. So the title here says that top 10 mistakes we make while writing programs. So let's begin. The first thing is know what you are writing the program for. Right, this happens a lot with me and my friends in college here, which is that we do not understand the question or we do not read the question properly and we simply start coding. Right. So the point is we just want to, get the basic syntax in place first and then we'll worry about the logic. So what we typically do or what we typically used to do is, we used to write the entire code, take the inputs and display the output as well. And then we used to worry about the logic. Right, but that is now how it is supposed to, that is not how it is supposed to work. It works the other way around. So take 5 minutes, read the program properly, read the question properly, or read the challenge properly, figure out how you're going to do it and then start coding. Because what happens is, if you directly, type the entire structure out or the entire skeleton of the code out and you're just waiting for the functionality part to pop in your mind, you get, you get that feeling that it is not working and it is easier for you to quit. So it is more likely that you will quit that particular code, or you will, switch to some making some other programs if you have the basic syntax in place first. So worry about the logic first and then type the syntax, because you know that you know what the syntax is. That is not a problem. The only problem is the logic. So take care of the logic first. Know what you're writing the program for before you start writing. The second mistake is, we don't read the errors, we directly jump to the code and we start looking at it line by line to figure out where we went wrong. So what happens is, there is a reason, there is something known as an error. Right? So just read the error first and the error will somehow point to the mistake. Right? And if you can understand what the mistake is, you can easily figure out which line of code needs to be fixed, and that is when you actually have to worry about the code. So don't start looking at the code immediately if you get an error. Read the error first, you'll figure out the solution and then go back to the code. So that is the second most common mistake that people make. Yeah, so the hello or the Python compiler directly compiles and displays it in a single command. So yes, the Python hello python.py will directly print the output if everything works fine. If the code is wrong, it will generate errors and it will show those errors out to you. Right. So the third mistake is, input related issues. I get almost every single day, I get around 5 to 6 messages where people are dealing with input related issues. Right. So it is, whenever you're worrying or whenever you get an error that is related to input, immediately go to the scanf statement, because obviously that is where you're taking the input. Right. That is where you're reading it. So the most common thing that you have done is, you might have missed the ampersand in case of C, or you must have misplaced or misnamed the variable in case of the other languages. So that is what is fundamental when you get any input related issues. So don't look anywhere else. If it is an input issue, directly go to scanf. That is the third most common mistake. Number four is, if the error you get is core dumped, right, or code dumped, it differs in different compilers. So yeah, whenever you get something which is called dumped, so either you have missed the semicolon in the scanf statement or you have added an extra one in the print statement. Now this is specific to C, right? So this ampersand thing is specific to C, and since most of you are still, learning C, this is the mistake number four that I need to point out. So whenever you get an error which is called dumped, directly go and check for the semicolons. So if it is dumped, scanf or printf is the problem, everything else is fine. Right. The fifth mistake is, try solving the problem at least 3 times before you ask someone. So, try fixing the error yourself before you ask for help. Now, I am not saying don't ask for help. You are always free to drop me a message, but it will improve your problem solving skills itself. Because if you face the same error 10 different times and you solve it yourself, you'll remember it forever, and you won't repeat the same mistake again. So try solving the problem at least 3 times before you ask someone. That is my mistake number 5, which can also be called as an advice. Right. Next is, if it is a warning, it's all good, don't freak out. So I have received a lot of queries related to warnings. They say that the code is running fine, which it will if it is a warning, because warnings are something that you might, it might lead to some trouble. But it's been like over 5 years since I have been coding, and never has a warning ever led me to trouble. Right. So if it is a warning, it's all good. There is no need to freak out. You can just ignore the warning altogether, because the code will run just fine. You'll get the proper output, and that is all you should be worried about. So just ignore the warnings. Now mistake 7 is use comments. God made them for a reason. The very basic reason why we have comments in the first place is to make sure that we type something out, or we make notes for ourselves in the code. Because trust me, if it is a hello program, it is fine, right? But if you open the project that you have made, after a few weeks or a few days, you will not remember what part of the code does what. And that is why it is crucial that you use comments in the code. Another important reason for that is, if you give that code to a friend, for some reason, and he will try to fix it, and he will try to fix it in his then it is very difficult to figure out which activity is which activity. So two things here: give meaningful names to variables and use comments. So in my projects, typically there are a lot of comments. So I write comments every 10, every 8 to 10 lines, stating what the next 10 lines do. So whenever I'm checking or whenever while as well for myself, I've mentioned everything so clearly in the comments that I don't have to go back line by line and check which part does what. So yeah, that is mistake number 7. Always use comments. I have seen people use no comments at all. So that is not good. When when you'll go and work for companies in the future, there you'll have to ensure that you keep a track of what you're doing, and comments are the way of doing that. So mistake number 8, always test the code for all possible cases. Now this typically happens whenever you're uploading the outputs that you upload. What happens is, you only check for the positive case. For example, if the code says check if the string is a palindrome or not, so you'll just check, or the output that you upload is only checking if the string is a palindrome. So I get to see only the true case, right? What happens if I enter something which is not a palindrome? You should check for that as well. It should show that it is not a palindrome. Yeah, so Khayati, it does not matter which topic or which concept you're working for. Warnings are meant to be ignored, right? That is it. That is the bottom line. Just ignore the warnings. If you have an error, that is when you should be worried. So you can directly ignore the warnings irrespective of what you're working with. Right. So as I was saying, for example, if I give you another question which says, check if a number is an Armstrong number or not. So that is when you should check for both the possible cases. If I enter a number which is an Armstrong number, is the code working fine? You should also check if the code is working fine if it is not an Armstrong number. So again, always test the code for all possible cases, because what happens is, this happened to me once in the lab class, right? So we had an exam going on, and I wrote the code and I tried it for the positive case, or the case that we were supposed to display to our faculty, right? And I said I tested it for the positive case and it was working fine. So I showed the code, I called the faculty and I showed the code, and he first tried it out for the positive case and it worked fine. Then he told me to enter an input which would result in the negative case, right, or the false case. And that is when I landed into trouble, because the code was not working properly for the wrong case. So that cost me a few marks there, right? So that is where I have learned that you should always test the code for all possible cases. Next is, make sure you have your semicolons in place. So at the end of every statement, you should enter a semicolon automatically, irrespective of whether it is allowed or not. For example, in Python, it is not allowed. It is optional. You can skip semicolons, but that is not what you should typically do. It is a good programming practice to enter semicolons every single time. and you should be careful to not enter those in the if or while statements, because if you enter the semicolon after the at the end of an if statement, if condition and then you write a semicolon, it won't work, right? So make sure you have your semicolons in proper places. That is mistake number 9. And the 10th mistake obviously is keep a track of the mistakes you fix and don't repeat them. So for example, if you know you have missed a semicolon before, what kind of error it leads to, the next time you get that error, you should automatically get back to that line, by yourself. You need not have to look or even think for a second. So make a lot of mistakes, but keep a track of the mistakes you fix and remember what led to what kind of a mistake. So that will automatically help you go back and fix it immediately. Right. So those are the 10 typical, most common mistakes that I have encountered myself and that I think you guys will encounter, sooner or later. So keep a track of all of these. Now I'll be sharing the link of this video and I'll share this PPT also if you want after the workshop. So sometime tomorrow probably, because this video will take a while to, buffer and upload. So I'll be sharing the link to the video. You can watch it afterwards as well. And I'll share the PPT also in the group. So yeah, that is about it for the presentation. So again, I'll stop for a 5-minute doubt clarification. So if you guys have any doubts, drop those in the live chat and I'll answer those. So I'll be letting the webinar continue for the next 5 minutes. So if you guys have any doubts, you can ask right now. You can always ask them later to me, in the message or in the group. So that is not a problem. But if you didn't understand anything that we discussed in this particular webinar, it is recommended that you ask it right away. So I'll be waiting for 5 minutes. And if you guys have any doubts, just drop them in the live chat. Or if you don't have any doubts, just type that you don't have any doubts so that I am not waiting for without a reason. So just type that you don't have any doubts and we'll end the webinar then. Right. So as you might have been told, we'll have such webinars every month. So once a month, or we can even have them once every 20 days or so. So this was the second webinar for all those who joined back in May or June, and everybody who joined in August, this was the first one for you guys. So if you want me to take a webinar on any particular topic, you can drop me a message regarding or mentioning the topic that you want. So the topic that I covered today in the first half was actually, requested in the previous webinar. So somebody asked me to tell how everything works in a Linux environment, and that is why I took it up this time. So if you want any particular topic to be discussed, you can drop a message. So as all of you are saying that you don't have any doubts. Okay, so Hitesh is asking what according to me is the best coding language to go ahead with. See, the point is that there is no best coding language. There is a reason we have so many languages, and the reason is that none of them is best for everything. So every language is good for one particular purpose, and it is the best when it comes to that particular thing. So for example, C and C++ are typically used these days for IoT and other such projects where you have to deal with hardware, because C and C++ are extremely good with machine. interacting with machines or other hardware. Java is used for developing Android applications through and through. So no application ever has, every single Android application uses Java. And Python is picking up like very fast. So Python is best or one of the best when it comes to backend web programming. So there is no particular language that is best. It is always good to know a lot of different languages because you'll have to pick the language according to what you're working with. Right. So again, there is no best programming language. Just pick according to the scenario that you're working in. So all right, that was it for this webinar then. Thank you so much guys for attending. And I'll share the link of this webinar and the presentation sometime tomorrow on the group. So thank you so much.